In this lesson, we'll be going over work, power, and efficiency. Starting off, work is done when there is a transfer of energy. Work acts on an object as the applied force. Work is measured in joules, which is newtons times meters. The conditions for work are that force must be exerted on an object, the object must be displaced by this force, and some of the force must be in the same direction as the displacement. Taking a look at this diagram over here, where a man is pushing a box with a force of 45 newtons, pushing the box 8 meters east. This is an example of following the conditions for work. As force is being exerted on an object, the object is being displaced because of the force, and the force is in the same direction that the box is moving. The variable for work can be W or delta E, which means a change in energy. For this example, and ones like it, it's better to use W, but in questions involving electronic devices, delta E is more appropriate. The formula for work is force times delta D, which can either be distance, height, or the overall change in position. Plugging in these units, 45 newtons east times 8 meters east, the work required for this man to push this box is 360 joules of energy. Let's move on to another practice problem. Calculate the work needed to pick up an 11 kilogram water jug and place it in a cabinet that is 2.3 meters above the floor. Like last question, we're solving for work. What's different is that we're not given the force. But not to worry, we can calculate force by multiplying the mass of the object by the gravity of Earth. So the formula would be work equals mass times gravity times delta D. And plugging in these units, work equals 11 kilograms times 9.81 newtons per kilogram times 2.3 meters. Kilograms cancel out, leaving us with newtons times meters, which is joules. And rounding to two significant digits, the work needed to lift up the water jug is 250 joules. Let's move on to power and efficiency. Power is the rate of work, basically how much work is done in a certain amount of time. So the formula is P equals delta E divided by delta T. Delta T represents the time taken for work to be done. Power is measured in watts, which is joules divided by seconds. Next is efficiency. The efficiency of a device is how well it works. Efficiency is measured by how much output energy is useful compared to the input energy. So the formula for efficiency would be the output divided by the input multiplied by 100%, because this number would turn out to be a decimal, and we would rather see everything in a percentage. Efficiency can either be for power or for work. Let's jump right into a question using both power and efficiency. A blender is used to make a grimace shake. Question A. If the shake took 20 seconds to blend, using an output power of 900 watts, how much work is the blender doing? So we know that the power formula is delta E divided by delta T. To isolate for work, we need to multiply both sides by time, and so work equals power times time. And now inputting the information that we are given, 900 watts times 20 seconds, this gives us 18.0 kilojoules of energy, rounding to three significant digits. Now moving on to question B. If an input power of 1100 watts was needed, how efficient is this blender? Well, we know that the efficiency formula is the output divided by the input. And since the blender output 900 watts, but needed to use 1100 watts, that means 200 watts of energy was not being transferred into the blender and turned into a different form of energy. And in this example, it was probably heat. Multiplying this by 100%, we get an efficiency of 82%. Finally, question C. Using this same blender twice every day for 20 seconds each time in a 31-day month, how many kilowatt hours of energy would the blender consume? First, what is a kilowatt hour? Well, we know that a watt is the unit for power. We also know that a kilogram is 1,000 grams. So that's no different from a kilowatt, which is just 1,000 watts. And so a kilowatt hour is how many kilowatts in an hour. To find how many of these would be consumed, we would have to convert the time into hours and the power into kilowatts. Starting with the time, If it takes 20 seconds for every blend, multiplied by 2 blends every day, multiplied by 31 days, divided by 60 seconds per minute, divided by 60 minutes per hour, crossing out all the units, leaving us with hours, and so 20 times 2 times 31 divided by 60 divided by 60, this gives us 0.344 hours. Then for the power, it takes 1100 watts for every blend. We have 2 blends a day multiplied by 31 days, divided by 1000 watts in a kilowatt, and all of our units cancel out. And then we can multiply 1100 times 2 times 31 divided by 1000. This gives us 68.2 kilowatts. And so plugging this in, 68.2 kilowatts times 0.344 hours. And the blender is using a total of 23 kilowatt hours across the 31 days, rounding to 2 significant digits. If you've made it this far into the video, chances are you're learning a lot and enjoy the content. So if you don't mind, consider subscribing and dropping a like on this video, as it shows me that you like what you see, which helps me post more videos. Anyways, that's it for now. I wish you well and hope you have a good day.